Good morning, students. Our today's topic in the subject of Pure Mathematics 3 A levels is trigonometry. And in trigonometry, we are going to read today is trigonometric identities. Okay, trigonometric identities. So the first thing that you have to learn and understand the formula tan theta is equal to sine theta over cos theta. Okay, and other formula is sine square theta plus cos square theta is equal to 1, and other formula is 1 plus tan square theta is equal to secant square theta, and other formula is 1 plus cot square theta is equal to cosecant square theta. Some more formulas are there. Sine is reciprocal of cosecant. Cos is reciprocal of secant. And tan is reciprocal of cotangent. So if tan theta is equal to sine theta over cos theta, so then cot theta, because we have learned that cot theta is the reciprocal of tan. So if tan theta is sine theta over cos theta, so reciprocal of this one will be equal to cos theta over sine theta. So these are some formulas which you have to learn and understand before doing your questions. So write these formulas in your copy, understand it, learn it, and now we are going to solve some questions. So concentrate yourself now. So here is the first identity which we have to prove. The question is 2 cos square x plus 3 sin x minus 3. Prove it equal to minus 2 sin square x plus 3 sin x minus 1. So suppose if we take left hand side, that is minus 2 cos square x plus 3 sin x minus 3. So we have to prove this identity equal to this. So if you look at the right hand side, there are only sine values, but on the left hand side value there is one cos x value. So we have to exchange this value into sine. So look at this formula. Sine square theta plus cos square theta is equal to 1. So that is this formula. Sine square x plus cos square x is equal to 1. So because cos square x is there in the question, so cos square x, leave this cos square x over here, and this sine square x will go to the right side, it will become negative. So this will be equal to cos square x equal to 1 minus sine square x. So we will put this value in place of this one. So look here now, this 2 will remain as it is, and in place of this we are going to place 1 minus sine square x. The rest of the values will remain as it is, that is 3 sin x minus 3. So now this 2 will be multiplied inside the bracket. So 2 minus 2 sin square x. Rest of the values will remain as it is, 3 sin x minus 3. So moving further, because we have to prove this, so this value will remain as it is now, minus 2 sine square x. Okay, then we need 3 sine x, so this value will be written after it. So plus 3 sine x, and after that 2 minus 3 will be equal to minus 1. So look now, the left hand side has been proved equal to right hand side. So look now, here is another question. We have to prove this identity equal to this one. So suppose if we take left hand side, that is 2 sine square x minus 5 cos x minus 4. So on the right hand side, if you see, there are only cos values are there. So we are actually going to replace this value into cos. So this is the formula again. So from here, if you see, sine square x will be equal to, so this is here. So cos square x will go to the right side. So it will become now 1 minus cos square x. So we are going to replace this value by this one. So look now, this 2 will remain as it is. Sine square x is equal to 1 minus cos square x. Rest of the values are still there. Open the bracket. So 2 minus 2 cos square x minus 5 cos x minus 4. So look at the right hand side now. We have to put this value first. So this value will be placed first. So minus 2 cos square x, then minus 5 cos x. So this value will be written after it. And 2 minus 4 will be equal to minus 2. So look at this. So we have proved. So this left hand side is equal to right hand side. Here is another identity which is required to be proved. So left hand side is, so look now, we have taken the left hand side, that is tan square x plus 2 whole divided by tan square x plus 1. So look at the right hand side. Actually, we want cos on the right hand side. So it means that these cos should be replaced, should be exchanged into cos. So look now, here is a formula. 1 plus tan square x is equal to secant square x, because secant is actually the reciprocal of cos. So we will use this formula. So look now. So if 1 plus tan square theta is equal to secant square theta, so tan square theta will be equal to secant square theta minus 1. So look now, tan square x will be equal to secant square x minus 1. This plus 2 will remain as it is. In the denominator as well, this tan square x will be equal to secant square x minus 1. This plus 1 will remain as it is. Moving further, so secant square x minus 1 plus 2 will be plus 1, and in denominator minus 1 will be cancelled by plus 1, so it will be equal to secant square x. Okay, look now, because secant square x is the reciprocal of cos x, so it means secant will be the reciprocal of cos. So look now, we are putting 1 over cos square x. This plus 1 will remain as it is. In the denominator, 1 over cos square x. So take the LCM in the numerator. The numerator will be 1 plus cos square x. This cos square x will be the LCM. And in the denominator, there is a fraction. This fraction will come to the numerator. We have to take the reciprocal of this one. So cos square x over 1. So at this step, if you see, this cos square x will be cancelled, and the remainder is 1 plus cos square x, which is equal to right hand side. So it is proved. So left hand side is equal to right hand side. Here is another question. Tan x over tan square x plus 1. We have to prove it equal to sin x into cos x. So it's tan into sin and cos. So this formula will be used because tan is equal to sin theta over cos theta. So left hand side, that is 10x over 10 square plus 1. So we are putting the value of tan theta into this one. So sine theta, sine x, because x is there, so sine x over cos x, and in denominator tan square x will be equal to sine square x over cos square x, and this plus 1 will remain as it is. So in numerator sine x over cos x, and in denominator you have to take the LCM, so that will be equal to sine square plus cos square. And in denominator LCM is cos square x. So moving ahead, sine x over cos x is still there, and in denominator sine square plus cos square. So look now, sine square theta plus cos square theta is equal to 1. So it means this factor will become 1. So, and the denominator will remain there. In the next step, sine x over cos x is still there. And in the denominator, we have a fraction now, 1 over cos square x. So when it will come to the numerator, so listen, one rule: when a fraction go from numerator to denominator or from denominator to numerator, we have to take the reciprocal of that one. So 1 over cos square x will become cos square x over 1 in the numerator. From here you will you can see one cos will be cancelled by this one. So the remainder will be sine x into cos x. So this is the right hand side, which is proved. Here is another question. Again, requirement is prove it. So 1 plus cos x over sine x plus sine x over 1 plus cos x is equal to 2 over sine x. So take left hand side, that is 1 plus cos x over sine x plus sine x over 1 plus cos x. Okay, this is the thing. Okay, now take LCM. LCM will be sine x into 1 plus cos x. So this sine x will be cancelled by this. So 1 plus cos x will be multiplied by this one. So it will become 1 plus cos x whole square plus 1 plus cos x will be cancelled by this. So sine x will be multiplied by this one. So it will become sine square x. Okay. Moving further. In this bracket, a plus b whole square formula will be applied. So open it. So a square plus b square plus 2ab. So 1 plus cos square x. Look here now. 1 plus cos square x plus 2 cos x. And this plus sine square x will remain as it is. And in the denominator, sine x will be multiplied inside. So sine x plus sine x cos x. Or write it as it is, because I think so it will be cancelled later. So look now, in the numerator now, sine square plus cos square, here is the formula, that is equal to 1. So this one is still there. Sine square plus cos square is equal to 1 also. And this is the thing, plus 2 cos x. And in the denominator we have sine x into 1 plus cos x, still there as it is. In the numerator you can see now this is 2 plus 2 cos x. So take 2 as a common. So inside the bracket will be 1 plus cos x. And in denominator we have sine x into 1 plus cos x. So look now, this bracket will be cancelled in numerator and denominator. So the remainder will be 2 over sin x, which is equal to right hand side. So left hand side has been proved equal to right hand side. Good morning, students. Our next topic in this topic of trigonometry is use of identities in solving trigonometrical equations. And here is a question. The statement is solve for. So here is the limit. X is greater than or equal to 0, lesser than or equal to 360. And here is a question. 2 cos square x plus 3 sin x minus 3 equal to 0. So here are two different trigonometrical ratios are there. So first we will make them one trigonometrical ratio. So cos square x will be equal to 1 minus sin square x from here. So we are going to put the value of cos square x into this one. So 2 into 1 minus sin square x. Rest of the values will remain as it is. 3 sin x minus 3 equal to 0. Open the bracket, it will become now 2 minus 2 sin square x. Rest of the values will remain as it is. So 3 sin x minus 3 equal to 0. Okay, further, minus 2 sin square x plus 3 sin x, and this 2 minus 3 will become minus 1. So take minus common throughout the equation. It will be 2 sin square x minus 3 sin x plus 1 equal to 0. So it has become a quadratic equation now. Think full factor as a x square. Think this full factor as a x. So actually the equation is 2x square minus 3x plus 1. So we will apply factorization method or the quadratic formula method. So look now, multiply the coefficient of the first one with the last one, that is 2, and the central coefficient is 3. So think a pair of numbers whose multiplication equal to this one, addition or subtraction equal to this one. So these will be 2 and 1. Write the central coefficient, that is sin x, with both of these values. Okay, now this sign is telling us that these two values will have the same sign, and this previous sign is telling us that the both values will have minus sign. So now we will put this factor in place of the central value. So it will become, first value will remain as it is, that is 2 sin square x. So minus 2 sin x minus sin x, and this plus 1 equal to 0 will remain as it is. So we have placed these two values in place of the central value. So now make pairs and take common. So in first pair 2 sin x is common, remainder is sin x minus 1. In the second pair minus 1 is common and the remainder is sin x minus 1. Okay, out of these two common brackets we will write one bracket. So sin x minus 1, and the values outside the bracket will be written in the second, that is 2 sin x minus 1 equal to 0 is still there. Okay, from here sin x is equal to 1, and from here sin x will be equal to 1 by 2. So we know sin 90 is 1. So it means x is 90 degree. So when the values come at the horizontal or the vertical line, these will be written as it is. But when the values come in the quadrants, So we have to solve it now. Look now, sine is positive. It means first and second quadrant will be there. Here is alpha, here is alpha. Okay, alpha is equal to sine inverse 1 by 2. And sine inverse 1 by 2 is 30 degree. So the original angle is x. So it means x will be equal to, first x is 90 degree, that will be written as it is. So that will be copied as it is now. And the second x is from here, this is alpha. And the second will be 180 minus alpha. Alpha is 30 degree. And 180 minus 30 will be equal to 150 degree. So combining these two values of the x will be ascending order should be arranged. So 30 degree, 90 degree, and 150 degree are the answers of this question within this range. Here is another question. This statement is again same. Solve for x greater than or equal to 0, lesser than or equal to 360. And here is the question. So if you look at the question, here are two different quantities. There are two different trigonometrical ratios. So first we will convert them into single one. So open the brackets now. So it will become 2 sin x minus 2 cos x. On the right hand side, open the bracket. So this will become 3 sin x plus 3 cos x. Okay. Shift this 2 sin x to right hand side. So it will become 3 sin x minus 2 sin x. And this 3 cos x will come to the left hand side. So minus 3 cos x. And this minus 2 cos x is still there. So the next step will be, it will become now minus 5 cos x. And on right hand side, we have a 1 sin x. So in the next step, this cos x will go to the right hand side. So sin x over cos x. On the left hand side, we have now 5. And sin x over cos x, you know, that is equal to tan x. So tan x is equal to minus 5. So the two different trigonometrical ratios have been converted into single one. So proceeding further, tan is negative, and tan is negative in second and fourth quadrant. So here will be alpha. Okay, from here, alpha will be equal to tan inverse 5. So tan inverse 5 will be equal to 78.69. Okay. Now the original angle will be equal to 180 minus alpha, and 360, because from here to here will be equal to 360 minus alpha. So putting values into these two things, so 180 minus 78.69 is equal to 101.31, and 360 minus 78.69 281.31. So these are the answers within this range. Here is another question. The statement of the question is the function f of x is equal to 5 sine square x plus 2 cos square x is defined for the domain x is greater than or equal to 0 and lesser than or equal to pi. So look at here. Here is pi now. It means the question is in radian mode now. So first you have to change your calculator from degree to radian mode. So this is the first thing that is required in the question. So moving ahead now. First part is express f of x in the form a plus b sine square x, stating the values of a and b. So look now, because the requirement is the required thing is only in sine, so we have to convert this cos square into sine. So look now, the thing is 5 sine square x. So 5 sine square x plus 2 cos square x. So this is the question. So now we are putting cos square x is equal to 1 minus sine square x. So because you can see from here, cos square theta will be equal to 1 minus sine square theta. Open the bracket now. So 5 sine square x plus 2 minus 2 sine square x. 5 sine square x minus 2 sine square x will be equal to 3 sine square x. Plus 2 is still there. So comparing this with this, a is equal to 2 and b is equal to 3. So these are the values of a and b. Moving further, the second part is find the values of x, for which f of x is equal to 5 sine x. So this is f of x now. So for the second part, it means 3 sine square x plus 2 will be equal to 5 sine x. Okay, this factor will come to the left hand side. So 3 sine square x minus 5 sine x plus 2 equal to 0. So this is a quadratic equation now. Think this full factor as x square, this full factor as x. So this is actually 3x square minus 5x plus 2. This is a quadratic equation. So we are going to solve this equation through factorization method. So multiply the coefficient of the first one with the last one. So it will become 6. Central coefficient is 5. Now think a pair of numbers whose addition multiplication is equal to this one. Addition or subtraction equal to this one. So the numbers will be 6 and 1. Okay, write the singular variable with it. So singular variable is sin x. This is quadratic variable. So sin x will be written with both of these values. Okay, now the last value is telling us that these two values will have same sign, and this sign is telling us that minus sign will be placed with both these values. So now we will write these two values in place of the central value. So look now, 3 sine square x will remain as it is, minus 6 sine x minus sine x and plus 2 equal to 0 will remain as it is. At this step, make pairs and take common. So from first pair, 3 sine x is common. Remainder is sine x minus 2. From the second pair, minus 1 is common and sine x minus 2 will be placed inside the bracket. The bracket which are same will be written once. So sine x minus 2, and the values outside the bracket will be written in the other bracket. So 3 sine x minus 1 equal to 0 is still there. From here sine x is equal to 2, and from here sine x will be equal to 1 by 3. Okay, from here you can see sine x value is 2. That will be not applicable because sine range is from 1 to minus 1. Okay, from here sine's value is positive, and sine is positive in first and second quadrant. So here will be alpha. So alpha will be equal to, so first change your calculator into radian mode. So I have changed my calculator into radian mode. So sine inverse 1 by 3. 1 by 3 is equal to 0.34. Now the angle x will be equal to alpha, and second angle will be 180 minus alpha. So putting values of alpha into these two will be equal to now 0.34, and 180 minus 0.34, 179.66. So these are the answers of this question. Here is another question. This statement is show that 10x into 1 minus sin x over cos x is equal to sin x plus sin x over 1 plus sin x. So first we have to prove this. So look now, here is the solution. Left hand side is 10x into 1 minus sin x over cos x. So we have to prove it into sine. So first convert the all quantities into sine and cos. So tan theta will be equal to sine x over cos x into 1 minus sin x is still there, and denominator is still there. So this cos x will be cancelled by this. Okay, no. These are in denominators now. So the thing will be, this sign will be multiplied inside the bracket. So sine x minus sine square x over cos x. And this cos x will go to the numerator and it will become 1 over cos x. Okay, moving further. Sin x minus sine square x over cos square x, because these two cos are multiplying with each other, and cos square x will be equal to 1 minus sine square x because we want all quantities into sine. So sin x minus sine square x over 1 minus sine square x. Okay. From this step, take sin x common from the numerator. So sin x into 1 minus sin x, and in denominator there are two squares, between them is minus, so a square minus b square formula will be applied, which is equal to a plus b into a minus b. So in denominator, it will become now 1 plus sine x into 1 minus sine x. The benefit of this one will be, this bracket will be cancelled by this one. So sine x over 1 plus sine x is the remainder, which has been proved equal to right hand side. So first part is done. Now second part is, hence solve the equation tan x into 1 minus sin x over cos x equal to 1 by 4 for x is greater than or equal to 0, lesser than or equal to 2 pi. So 2 pi is showing that. Change your calculator into radian mod. Okay, this factor has been proved equal to this one. So it means sin x over 1 plus sin x. So second part, sin x over 1 plus sin x. So this function is equal to 1 by 4 now. So take it equal to 1 by 4. From here 4 sin x equal to 1 plus sin x. So we have cross multiplied the values. Sin x will come to the left hand side. It will become 3 sin x equal to 1 is still there. Okay, from here sin x will be equal to 1 by 3. So sine's value is positive, and sine is positive in first and second quadrant, and alpha will be equal to sine inverse 1 by 3. First, change your calculator into radian mod and then find sine inverse 1 by 3. That is 0.34. So the original angle is now x is equal to alpha, and from here to here pi minus alpha. So putting values into this one, alpha is 0.34 and pi minus 0.34. So 0.34 and solve it on the calculator. So pi minus 0.34, that is equal to 2.80. So these are the answers.